Good morning, students. Welcome to Friday, one of the first Fridays of the semester, and today we are going to be discussing lab safety. As we start out the semester, it's super important that you guys have a better understanding of lab safety and how we can all stay safe in the classroom when we're conducting lab and different experiments, when we're around all these different chemicals. It's extremely important for you guys to be aware of the do's and the don'ts of lab safety. So I've handed out a packet, a safety packet. It includes a bunch of different information for you. The most important thing, it's all important, but one of the most important things in that packet is going to be our lab safety rules and requirements. So in your packet, you'll find that list of rules that I want you guys to go over and look through. And then at the bottom, there's a spot for you to sign. And there's also a spot for your parents to sign. So go ahead and once you get home tonight, look over those safety rules. And as we go through class today, we'll be looking at those different rules. You sign it, your parents sign it, and put a date on it and bring it back to me so that we're all on the same page as far as lab safety rules goes. So to introduce us to a little bit of lab safety, I have this awesome video for you guys to watch. It's hilarious, but there's also a lot of good information in here. So let's take a look.
Working in the lab and I'm thinking about safety. My goggles drawn and my coat's on. Open toe shoes out of here. Are you going crazy? Things could go wrong. Things could go wrong. My gloves, they make you safe around chemicals. The chemicals. My gloves, tie back your hair and prep materials. The materials. One, don't you taste a sniff? You know you should be wafting if you're taking a whiff. Two, don't mix it in until the label's checked again. Three, no food or drink unless you want to have a funny dead in the morning. And if you follow this, you won't mitigate the risk. I got all rules, I count 'em. I got my rules, I count 'em. All here, take back and pass 'em. I got my rules, I count 'em. One, don't you taste or sniff? You know you should be wafting if you're taking a whiff. Two, don't mix it in until the label's checked again. Three, no food or drink unless you want to have a scratch or dead in the morning. And if you follow this, you won't mitigate the risk. I got my rules, I count 'em. Thank you so much for watching.
Okay, you guys, so that is our intro video. Obviously, it's a little bit silly, but I think it makes a bunch of good points for us to take a look at. So just take about a minute or so and turn to your partner next to you and discuss. I want you guys to discuss what policies and rules did you observe from the video, and why do you think that those policies or rules are so important? So go ahead and turn and talk. Take about 1 minute and we'll have a class discussion when you guys are done. Okay, you guys, let's bring it back together. So let's talk about what did you guys think? I know, yes, Tracy, what did you think? What did you hear and what did you observe was important from that video? Absolutely, wearing goggles is incredibly important. And why do you think that that's important? Yes, we never want to spill chemicals in our eyes. Safety goggles are incredibly important. They're our best defense against splashback. Um, Dangerous fumes could potentially come into contact with our eyes. Those are great, important topics. Absolutely. Who else? Who else saw something in that video? Yes, Garrett. What did you see? Yes, no sniffing any chemicals directly. If we want to sniff a chemical, we definitely want to waft instead of directly sniff so that we don't get fumes directly up our nostrils. Instead, it's a secondary smell. And that's incredibly important. Why do you think, Garrett? Yeah, exactly. We don't want to burn our nose. We don't want to inhale something directly. We don't want to burn our noses. Exactly. That's totally correct. All right, you guys. So yes, I think there was a lot of good information in that video. They mentioned wearing lab coats, but in our class we don't have lab coats. So, when you come to chemistry lab, it might be a good idea to wear clothes that you don't care about, just in case something does spill on you. Wearing safety goggles, making sure our hair is tied up, especially when we use flames. Ladies or gentlemen who have long hair, I'm talking to either one of you. You never want to get your hair caught into a flame. That is for sure. No sniffing. Yeah, let's take a little bit closer look on some of the other important rules that we have. Yes, they mentioned no eating or drinking in the lab. They briefly mentioned no open-toed shoes. So in lab, we always want to be wearing closed-toed shoes just in case we were to spill chemicals, and they would automatically end up on our feet. So closed-toed shoes are a must. Check the labels before mixing chemicals. I'll always give you a heads up, you guys, on the types of chemicals that we're going to be mixing and what to be wary of. But we always want to check labels before we mix things. No tasting or obviously no tasting. I think that you guys probably have a great idea of why we shouldn't ever taste anything. There may be some times during some labs where we might be able to taste, but I'll make sure I let you guys know. And hair tied back. So you guys, these are some things I wanted us to take a look at part of this video and take a look at this picture. These are some of the things that could possibly happen when we don't follow safety procedures. So this young woman pictured on the left, she obviously forgot to wear closed-toed shoes. So her professor made her wear gloves on her feet, which I think is hilarious. So if you ever wear flip-flops, you might end up wearing gloves on your feet. It's a possibility. Then let's take a look at part of this other video. I just think that it's cool for you guys to see what could possibly happen if we don't follow procedures. So let's take a look.
While these accidents are always tragic, they could have been prevented. In this video, we will reenact 2 common laboratory accidents, explain what caused them, and discuss the safety precautions necessary to prevent them. Please watch this video and commit yourself and all your science teachers to continuous and ongoing lab safety education. It is only through education that we can ensure future safety. The first lab accident we are going to show you is what happened when a teacher added methyl alcohol directly onto a hot container. What we are going to show you is extremely dangerous, but it's vital that you see it in order to truly understand the risk. This sequence was filmed outdoors using a special pneumatic device. Heat is the ignition source. When methyl alcohol liquid and vapor reach the hot surface, they immediately ignite. The fire travels back along the vapor trail to its source, and the result is an instantaneous flash fire and explosion. With continuous and ongoing lab safety training, this never has to occur in a classroom.
Teachers should be trained to understand the importance of following a rigorous safety checklist when using methyl alcohol or any flammable liquid.
Okay, you guys, then let's take a look at one more situation.
typical soda bottle and dry ice. This reaction produces a gas and causes the pressure inside the bottle to increase. This will eventually cause the bottle to explode.
So obviously you guys can see how dangerous that could be. Dry ice just in a closed container with another chemical, and things can get really ugly really quick. So we definitely want to be careful and wary about what we're doing, when we're doing it, and be very cautious when we're working in lab. Here's one more video I wanted to show you guys. This woman is actually a science educator, and she was doing this video for PBS, and you know, she didn't expect for this to happen, and let's see if we can figure out where she went wrong.
Right, so what the chemistry that is behind this little bit of magic is that we are going to soak the $20 bill. You can use a $50 bill, a $100 bill. The more, the more monetary value it is, the bigger shock value. If you're a magician, you hide it, right? You don't show your audience that you have soaked it in anything. Chemistry teachers, though, typically want to teach some of the chemistry behind it. And so what I have in this tub is a mixture of alcohol and water, right? So rubbing alcohol that you would buy at the drugstore. And there's a little bit of water in it. And what I'm going to do is soak the bill in there. And then I do have, I'm protecting my eyes with the glasses. I am, some people actually hold the 20. I'm going to use a set of tongs so that my hand isn't so close to it. Okay. And so we have this $20 bill. It's been soaked in the alcohol and the water. And then you hold a flame to it, right? And up goes the $20 bill, so you think, right? And it continues, although that's...
So let's pause and think here, guys. What do you think that she should do at this point? The bill has actually caught on fire, and she proceeds to dump it back into the alcohol. Instead, what should she have done? Yes, she should not have put it back into that alcohol. Let's watch.
Give me 1 second. That didn't work.
There she goes. Then she figures out she's actually causing more flames to the fire. So sometimes when things like that happen, we don't really think it through of what's the next right thing to do. So staying calm, staying mindful of what chemicals you're using, and what kind of reactions can occur when you're using them is a critically important skill to have in lab.
Right. So.
Okay, you guys, here's one more demo. Usually I would demo this on the overhead, but since we're virtual right now, I want to show you guys what will happen when an egg and sulfuric acid mix. And this is a great demo because this is why we wear safety goggles, especially when we're using chemicals and any kind of acid. This is the egg represents our eyeballs, and the acid obviously is something that we can possibly use in lab quite often. So here we go.
One demonstration I performed on the first day of school was cooking an egg in sulfuric acid. You can imagine this egg as a human eye, and the sulfuric acid immediately starts destroying the proteins. This demonstrates the importance of wearing safety goggles. Safety should always be considered before working in the laboratory. Check out my profile for more.
So as you guys can see, that's pretty nasty. We don't want our eyes to be looking like that. So for the next 5 to 7 minutes, you guys, I want you guys to work in groups of 2 to 3. I have this little comic strip. I've already passed that out to you guys. It's in your safety packet. And I want you guys to identify the unsafe behaviors in the chemistry lab cartoon on a separate piece of paper. Make a list of each infraction that's found and explain why it's unsafe. Take the next 5 to 7 minutes, work in groups of 3 or 4. See how many you guys can come up with. Okay, you guys, great job. Now, for next Monday, this is your task that you have to complete in groups of 2 or 3. I want you guys to create a video, a poster, a song, or any other creative to display your knowledge on lab safety. Feel free to utilize